Hi guys, this video is going to be really quick. It's just about simplifying powers of I. I'm going to go through the notes that we took in class in case you are confused. So basically when you raise I to any power, you can simplify it down to one of four possible answers. The four possible answers are either I, -1, negative I, or positive 1. Every I to any power is going to be one of those options. So I to the first, that's the first one here, that's just regular I because, well, if you have a power of 1, an exponent of 1, it stays the same. Duh. Okay, for I squared, that's -1. That's the one we've been doing a lot in class. The reason there is because I squared, well, I is equal to the square root of -1. And if you square a square root, those two cancel and you're left with -1. Now we come down here to I to the third, and what that equals is negative I. And the reason is you can write out I to the third in expanded form, I times I times I. But those first two I's, I squared here, that we know is equal to -1. So really what you have is -1 times I, or in other words, negative I. I to the fourth, well, that equals +1. The reason for that is that I to the fourth is I times I times I times I. Each of these pairs makes an I squared. So it's really I squared times I squared, -1 times -1, which is +1. Well, now what happens when we go on to I to the fifth? So now we have I times I times I times I times I. Those first four are equal to I to the fourth, which we knew from the previous problem is just equal to 1. So really this is 1 times I, which is just I. And then we can keep going. So next up on here we have I to the sixth. So when I write that out in expanded form, I have 1, 2, 3, 4, 5, 6 I's. I group the first four of them together and basically ignore that because I to the fourth is equal to 1. And I'm just looking at how many I'm left over with. In this case, it's 2. So really, I to the sixth is the same as I squared, which I happen to know is -1. I to the seventh, what I'm really thinking to myself is, what is the remainder, or how many are left over once I divide by 4? Because what I have here is 1, 2, 3, 4, 5, 6, 7 I's. The first four make number 1. Times I have I to the third left over, and we already know from the previous page that I to the third is equal to -I. And this continues as such. I to the eighth would be I to the fourth times I to the fourth. Each one of those is equal to 1, so 1 times 1 is equal to 1. You can keep going like this. 9, if I divide by 8, really divide by 4, I have two groups of 4, 1 left over. 1 times I, my answer is I. So I can actually do this for way bigger numbers. I can think of, for example, I to the 42nd. Well, here's what I'm thinking. 42. If I divide 42 into groups of 4, there's going to be 10 groups. 4, 4, 4, 4, 4, that's 5, 6, 7, 8, 9, 10. 10 groups, that's 40. And what I'm left over with is 2. Well, each one of these is an I to the fourth plus I squared left over. The remainder, when you have 42 divided by 4, is equal to 2. So I to the 42nd is the same as I squared, because really what I have is 10 groups of I to the fourth. Each one of those is equal to 1. 1 times 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 1. That all cancels because 1 times 1 times 1 times 1 times 1 is just 1. What I'm left with is times I squared, which is equal to -1. So really what I'm doing is I'm just saying, okay, what's the closest multiple of 4? That's 40. So all of those are going to have equal to 1, and then I have 2 leftover i's, which would be I squared, which is -1. Sometimes you'll see this done with long division. For example, I to the 537th, let's say. I want to know how many 4s go into this and really what the remainder is. So I'm going to do 537 divided by 4. 4 goes into 5 one time, that's 4. Subtract, bring down the 3. 4 goes into 13 3 times, that's 12. Subtract, bring down the 7. 4 goes into 17 4 times, that's 16. Subtract. This is my remainder. Now, I actually don't care at all about this number. This number I don't care about. All I care about is this number here, because this tells me that this is the same as I to whatever this number is, to the first, which is just I. Hope that helps.